Hi everyone, this is Plasma Call number 15, and let's get to it. Anyone have updates? And then after that, we could go into different topics.
We've been doing a bunch of discussions around Plasma Debit lately. And yeah, maybe we could continue or like do a short like catching up on the topic, and maybe we can start discussing.
Yeah, that sounds fun.
Dan, as the inventor, do you want to?
Well, no, I think you've been doing awesome work on it. So the basic idea, just to recap for people, the basic idea of Plasma Debit is to have a single, it's Plasma Cash, but with each coin is owned, part of it is owned, the user has a balance in it, but the rest is owned by the operator. So it acts more like a payment channel. This one coin acts like a payment channel rather than acting like just sort of a single non-fungible, non-splittable thing owned by a single party. And then to do payments from one party to another, instead of transferring your channel to someone, you do basically a lightning style multi-hop payment where your balance goes down in your channel and someone else's balance goes up in theirs. So what Plasma Debit basically gives you is payment channels, but where you can join a payment channel with no on-chain transaction, because that Plasma Cash thing where you can transfer a channel to someone else, where you transfer a coin to somebody else, is still possible in Plasma Debit. So in Plasma Debit, you can transfer your channel to somebody else with no on-chain transaction. So that's sort of the value of it. And it also gives you additional interesting guarantees around atomicity. If you have two different transactions on different channels, you don't actually need to use an HCLC to make sure that they're atomic. I think Carl and Kelvin and Georgios and Alex and a few others have been, and Hayden have been working on getting a Plasma Debit spec. And we sort of just been kicking that around, and I think it's looking somewhat better, and hopefully soon will be we can publish it for review.
Yeah, that sounds awesome.
So the main thing that I've been trying to get around is how we would be able to include two transactions that are dependent on each other, so that if one gets included and the other does not, the one gets cancelled. Because we want that in Plasma Debit in order to do the thing where we take the balance of one coin down and we increase the balance of the other coin. And the scheme, so we thought of a scheme, and I would like to make a short discussion on it, on how it works. Also, we have Eric on the call, who is has been working on us with this. So hi, Eric. So yeah, the thing is, the scheme works as follows. So we have the receiver. So let's say that we have a user with a 5 out of 5 coin and another user with a 3 out of 5 coin. So, and the sender wants to make a 2 Ether payment to the receiver. What we will do is, firstly, the receiver, they will sign a transaction that increases their balance by 2. So the state of the coin was at 3 out of 5, the new state of the coin becomes 5 out of 5. And then we take that along with the other parameters. So we keep the owner the same. So the thing is that with a Plasma Debit transaction, the owner of the coin does not change. Like the coin history does not change. We just update the coin's state, in a sense. And we take the transaction hash of this updated state of the coin. We give it to the sender, and the sender uses this transaction and puts it in the transaction of his own that reduces his balance, like a dependency, like a dependent transaction. And so the sender then, they hash this whole thing, and that is the new transaction hash. So essentially you put the receiving transaction, you generate it, and you embed it inside the sending transaction. And in order to prove that, that way I believe that you can prove that the sending transaction is valid if and only if the receiving transaction was also included. And this is done so that it doesn't happen that you lose like 2 Ether, but you don't have proof that the receiver got the money. Does it make sense? I think, Dan, I think I said it correctly. Maybe you have any corrections on it?
That sounds exactly right. And so I think right now, because we're focused on the idea of one-way sort of payments, we're looking at these sort of atomic transactions as being like one-way dependencies, where one of the transactions is dependent on the other, but that doesn't mean that this transaction is dependent back.
Exactly, because the receiver does not care that the sender's balance goes down, but the sender needs to know that the receiver's balance went up, because in a real world transaction you need to prove, because otherwise the receiver can just say, no, I didn't get the money, I'm not giving you the product.
Right.
So the sender needs to be able to prove that the receiver's balance was actually increased. That's why we need to do this whole dependency thing.
Right. Yeah, go ahead.
So I haven't thought about this topic yet. Is there a reason why you're not wrapping it effectively into a single transaction and then you're splitting it up into sendings and receiving?
So yeah, I mean, one reason is that it's simpler to verify if one half of the transaction is only, because that's all we need really is to have one side of the transaction be dependent on the other. We don't need the reverse. And so that coin's history is actually simpler because it doesn't actually, the receiving coin's history doesn't have to include the two-part transaction. So it's an optimization slightly.
Oh, so the thinking is you don't have to include the entire transaction? Is that what it is?
You have to, so on the receiving side, you only need to include the receiving part because that part is not atomic on, like that part does not depend on anything else. So it's a weird concept to even to sort of be thinking about transactions that are like partially atomic or sort of one-way atomic. But the idea here is when you're receiving a payment, you don't actually care that the sender sent it. You just care that you receive it. And it's the operator's job, because the operator is including transactions. It's their job to keep themselves from being screwed by making sure that when they include this one, they also include the sending one. But it isn't the receiver's. The receiver doesn't really care about whether the sender actually sent it or not.
Got it.
So it's sort of an optimization, and it's one that I wonder if.
Because otherwise you have to include the entire set.
Yeah. So right. So it's just sort of larger
than the entire block.
Yep. So you do have to include both sides of both parts of the transaction, and like the sending transaction that has to be twice as big, but the receiving transaction only has to be half as big because it doesn't actually have any dependencies.
Yeah.
For what it's worth, the receiving transaction looks like a normal one-way payment with the operator.
Yep.
Yeah.
Georgius, did you get any additional information on just being able to do this in one swoop from Twitter, or any other insights there versus doing this two-step process?
No, I'm not. So I asked in Twitter, how can we do this in another way without some HTLC included to do the whole revealing game, to do the atomic transactions, but there was no actual insight. I think Jeff Coleman wrote some things, but I didn't really understand them.
He just said use state channels.
Yeah. He recommended to use a payment channel there, but I think I wasn't sure how we could use it, how we could make a construction. Maybe Ranjit, did you do any discussion on that, perhaps?
Not with him, but yeah, I feel like this might be easier to design off-chain rather than on-chain. That's as well.
So what do you have in mind?
I would, let me think.
Essentially, you could design it so that you may not have the sender get complete data, only that, some information is revealed or something like that, perhaps.
I have a short question.
What was the question? Because Georgius, what was the question you were asking on Twitter exactly?
So I asked, give me
Because I mean, on Plasma Debit, you don't need, or on Plasma Cash, you don't need HTLCs to do an atomic transaction, right?
Yeah.
Given that we do this thing that we mentioned just now.
Dependencies, yeah.
Right, but the dependencies, I don't think that this works for transactions that change ownership. I believe that that we discussed this. That this scheme only works if the ownership of both coins stays the same. Because if we do the other construct, I believe that because the ownership of the coins change, it's like two normal Plasma Cash transactions. So you need to also verify the whole coin history. I'm not sure, but I believe that it's more complex.
Not the entire. You don't need to verify the entire coin's history. You just need to verify to the previous transaction, because the parties that are transacting, so if Alice and Bob are doing a transaction, right? And Alice gives it to Bob and Bob gives it to Alice. Alice and Bob can be responsible for verifying the other's history up until the latest transaction. Like they can do that off chain before they even sign the transaction. So when they sign a transaction that says like, here's the latest transaction in Alice, here's the latest transaction in Bob's, and we're just having both these be dependent on each other, their security doesn't depend on like some later owner who's receiving this coin verifying that the entire history is valid. They know that the other's history is valid. So when they're doing this trade, they're going in eyes open. So all you need in that case, and this is not a problem in Plasma Debit, but you do need it when you have a Plasma Cash, when you have an ownership transfer and an atomic transfer transaction.
I think a more clear is that if you did like an HTLC like construction, you're adding another round is effectively what you're doing if you do it like that way. If you do it the way that you guys have described, you're eliminating the need for the reveal round.
Yeah,
effectively.
Oh yeah, it's definitely faster.
Yeah.
And
so I think that's probably the biggest gain. Probably.
It is the biggest gain. Yeah.
What's wrong with adding a round?
Oh, it's just more code.
Rounds are always bad. It's slower. It's more complicated. HTLCs suck, man. I'm sorry.
Yeah.
I'm sorry, Joseph.
But if you
if you have to have it, then you have to have it.
Yes, you do. Yes, you do.
And and then it's the optimization with HTLCs is primarily around root chain state pushing, because obviously with state channels, it's a bit expensive to be pushing like input transactions and output transactions across the board and revealing that data unnecessarily on the chain. But with this, if you presume that chain state is cheap on the Plasma chain, then it seems to perhaps work. But if it is expensive, then you may want to do the other way. I guess you can build in compatibility for both, but really it sounds like this way probably is probably like simpler to write, I guess.
Yep. So one other topic we've been talking about, and this is, I think, is impossible in Plasma Cash, as far as we can tell, is doing atomic transactions in a way that is safe from operator griefing. So this is to make sure that, like, if you and your counterparty have signed a transaction and submitted it to the operator, but then the operator starts producing unavailable blocks. In Plasma MVP and in Plasma Cash, maybe you can do this construction called a limbo exit, where you exit basically one specific transaction and say, like, you can have someone put up a bond. It's a little complicated, but it's a way to sort of make sure that neither the sender nor the recipient can be griefed by the operator. And by griefed, I mean attempt an invalid exit. So this is trying to preserve the property that no honest party will ever lose a deposit. And I think it's impossible once you get atomic transactions in this. And also, I'm not sure that limbo exits are necessarily worth it, as far as, like, they add a lot of complexity for a very specific, simple case of just sort of like a single transfer from one party to another. So I think, and Kelvin kind of convinced me of this, I think it may be worth just biting the bullet and saying, if the operator starts producing unavailable blocks and you have an in-flight transaction, and your counterparty is dishonest, you might lose a deposit. You might get griefed. But that's just one deposit, and that can be like $5 or something. It's supposed to basically pay the gas price of the challenger. So that's just sort of something that you might have to instead of having limbo exits, we might just say you have to attempt an exit, And if you get challenged on it, now at least you know what the correct place to exit from is.
And there's like possibly no penalties on that one or something.
I mean, if we have no penalties on that, then that's a problem, because then anyone can basically exit the last coin. It basically allows anyone to revert one transaction.
I mean, you have to bond it, but yeah, I know what you mean. Yeah,
right. Yeah. So I mean, it's the penalty should, again, it should be like relatively small, just sort of enough to ensure that the counterparty can pay the gas.
Yeah. Like basically gas only.
Yeah.
Yeah, exactly.
And we also said that, for example, there's no need to go for all the features in one. We can have like this sort of like modular approach where we can say that if you get the atomic swap feature, or whatever we want to call it, you may be griefed. Like it's a trade-off in a sense. Like, okay, maybe it's a marketing scheme, but whatever. But like, I believe that it's reasonable to say that for some features that we want, there will be some limitations.
I think that something that we talked about earlier, I'm kind of new here. Hi, everybody.
Maybe introduce yourself as well.
I'm Eric. I do independent open source dev and just try and put out like information to the community. So I think that we don't necessarily have to worry about griefing in this early implementation, because anybody can go to chain and exit accordingly. And then I think that at some point we'll be able to have multiple implementations of Plasma Debit or Plasma Cash, whatever, and that people will be able to move freely around to these other Plasma chains, and that those with griefing operators will slowly see a attrition. So I feel like that'll end up working itself out over time.
Yeah, I mean, I think as long as the griefing is capped by some small amount, like if it's like $10, and you can just say you only sign on to a chain, and that's you're agreeing that in this unlikely eventuality that you have a transaction in flight and the operator only then suddenly decides to go rogue, they may be able to grief you by $10. That's just sort of a capped amount of liability there of loss. And you say, I'm willing, that's a risk I'm willing to accept. And since you as a user are evaluating which chain you're getting on, you maybe say like, it's sort of okay to have reputation-ish games there.
Yeah.
Yeah.
I mean, you already have a reputation thing because you're sending your coins to the Plasma chain, right?
Right.
So
they can grief you by holding your coins
exactly.
for a week or whatever, right?
Yeah.
That's potentially more damaging than losing $10.
Yeah.
Depending on how much you have in that chain.
Exactly.
Yeah.
You can also possibly get around it in other ways. One thing you can do is add another round whereby the operator proposes a format, and then that basically adds one round to it, which is kind of annoying though.
I think that ends up resembling confirmation signatures.
Yeah. You
definitely can. One weird thought I had was you can just say every transaction is revertible. You can always revert one transaction. And then just whenever you want to do an actual transaction that's unrevertible, you just do it twice. And that, but I mean, I think just the sort of, and that actually weirdly enough, that doesn't add that much complexity to the contract, but adds a lot of complexity on the user side that literally adds to.
Well, on the client code base, on the node code base.
Yeah, exactly. And with that, this is the way that Pundraja channels avoid this, right? Is that the information that allows you to exit from the later round is given first, and then the information that invalidates the old round. Right. So like if you do it in 2 steps that way, then you can sort of avoid the grieving problem. I'm not necessarily sure it's worth it though.
Yeah. The time delays could end up getting pretty big if that's the case. I think there might be other ways to do it. I'll think about it.
I think the 2 round thing is not enough, because like you want to prevent people from trying to quote unquote limbo exit very old transactions, and the chain
because
you have a spend of that if it's a very old transaction.
You have a spend of that, but you can't distinguish between the case where someone is doing that and when someone has the person you're paying money to someone, that person colludes with the operator to withhold that, and then that person spends that a lot of times.
Oh yeah, when you change of ownership. That's right. So I think
Wait, why would that be a problem?
because I don't know if they sent it. Like Alice sends it to Bob.
Yeah, can we have an example of?
No, I'm presuming that this is like a really slow confirmation process, right?
Right. The
Like
problem here is right. Yeah.
If
If Alice transfers the coin to Bob, she doesn't know if Bob has gone on to spend it a lot. So if she tries to limbo exit, then like Bob can always just challenge it. She doesn't know Bob can't just like challenge it from saying, no, that's a really old coin. That was years ago. I've done a lot of stuff since then.
They have proof that that's the case.
What's that?
They have proof that that's the case.
Yeah, but Alice doesn't know. So Alice can't withdraw. And then so the problem is if you have an atomic transaction with 2 coins and Alice is the recipient on one and Bob is the recipient on the other.
Oh yeah, they'll have to download everything, which is why you have to do a proposed commit possibly.
Right, but what's that?
You do a propose, it gets included into a block, and then at that point, so you have to wait.
What happens if the other party disappears after the propose? Because you have to lock it into that state.
Then you basically, get logic in the contract to be able to submit something which is not committed, basically.
Right, but I think you need a timeout on it. Because like if we put our stuff into a prepare phase and then the other party disappears, then my stuff is locked up in that until.
Yeah. Then you need a timeout to get a refund. Yeah.
So it ends up sort of looking kind of like an HTLC.
Yeah.
You have like these particular time locked stages. You don't have hash information, but yeah.
Yeah, but you don't need to be decrementing. But basically, it's just like great if they don't submit it within 5 blocks, the transfer didn't go through, kind of thing.
Right.
But isn't this the same with target block?
With what?
With the target block in the transaction.
Right. Target block is very, very tight time lock.
Yeah.
Right. But I mean, I think generally I would rather have open up to griefing by the operator than griefing by any counterparty. Mm-hmm. And I count delaying a trend, like locking up my money for some amount of time. If we've got this prepare, commit, whatever. Locking up my money for some amount of time counts as griefing. So I think, I mean, maybe it can be short enough. I don't know. But yeah, and also it's pretty complex. So I would rather just say we got this case where the operator can give you $10.
The nice thing is it'll be pretty obvious to everyone when the operator is griefing anyway. For an extended period of time.
You'll see a lot, right? You'll see a lot of exits, and maybe a lot of inbound exits. So that's in
And they can prove it because they're just like, here's what I'm trying to exit with. I can't get this block data, and you're like, oh wow, I can't get this block either. And then yes. I do think the operator by default shouldn't be showing everyone all the plasma cache blocks. But but I'm just saying, there are probably ways available. Right. There's ways that someone who is live at the time can detect that that this is happening.
Are you sure? I mean, like, if the operator is like, oh, I'm not showing you the block, that subsection of the block, just because you're not, registered.
I mean, what if we say as part of the protocol that anyone can tell the operator you're allowed to show my block to somebody.
There we go.
Or you had some key or something like that was unique per transaction. So basically you rolled it, you hashed it once with a key with some nonce, and then that way you can individually provide an individual request.
Right. But the idea here is like I need to be able to prove to this third party that the operator is recalcitrant, right?
So essentially, in order to do the request, you have to provide some key. So
it's like a MAC agreement.
Yeah.
Right, but so in some way, someone else who's live can be like, oh yeah, that's totally true.
You mean that's the equivalent of like the hardened key derivation.
Sure, yeah.
I actually think that the problem you talked about, there's a solution to it that's not a full solution, but it's strictly better than confirmation signatures.
Right.
Which is that you adopt the idea of like revocation from Lightning Network. So like you start with a scheme where there's no bonds for anything, and then we know that is safe, but it has a high like griefability from random people. But you also have a rule that like people can give up their ability to grief each other by revealing and so the exit game says that. If I prove that if this person has already promised not to not to exit this coin, then they get penalized. So the idea, hopefully, with this is that these secrets that are basically promises, verifiable promises not to grieve people, they should be worth very little. Like if you quantify how much and hopefully people will people will make the payment, and then from the UI point of view, they see it go in, and then they hopefully they
you have to keep all these signatures around though forever.
Yeah, that's one, one downside inherits from confirmation signatures.
Right.
We can compress.
Can we do? I think at this point the discussion has been quite extended. Maybe we should do a recap. Maybe to make sure we're all in context. So this was around doing atomic transfers for coins that change ownership. Is that correct? Yes.
Yeah, I think that's the general problem.
So let's maybe try to summarize some main takeaways for our listeners.
So what we're trying to avoid is a problem where if two parties do a transaction where Alice receives one coin and Bob receives the other, and the operator goes rogue while the transaction is in flight, there's no we were not sure that there's a way for all the parties to if any one of those parties is honest, for them to avoid being griefed by trying to have to exit an invalid ballot.
Which happens. Which the worst thing that can happen is that the counterparty colludes with the operator, and they either get the bond or they get the payment does not settle.
Well, so the payment not settling is not necessarily a problem if it's in flight, because that's just the last payment. So that's not necessarily the worst. But if you either the problem here basically is that either you'll get the transfer will go through or it won't. The problem is to find out whether it will or won't, or to force it to do one of those. You might have to, because the data's unavailable, you might have to lose a bond.
Right. To be clear, the bond that we're talking about could potentially be pretty small here if the bond is basically paying for the transaction fees.
It's paying for
basically the gas costs.
This is the start exit fee, because when you start an exit, you also need to put a bond for potential challengers.
Yeah.
So essentially, the price that the user loses is bond plus gas.
Yeah, but effectively the gas price, you could be only paying the gas price or something like that, plus some small.
Okay. Yeah. Okay.
Make it pretty small.
Yeah, I mean, there's a bit of a worry because if to make it actually worth it, you want the gas. We don't know what the gas price is necessarily going to be, so you might have to make it a little higher because of the possibility.
Right.
Of
but we can use gas token. We can use built-in gas token in the construction.
Yeah.
Okay, so I think this brings us to a more general concern, because limbo exits and in-flight transaction, the only issue is the bonds. Let's ignore gas. It's safe, I believe, to ignore gas, for 80,000 gas, for example, or 70,000 gas. In this case, it revolves around pricing bonds. This is what the problem reduces to, I believe. And so far, I tried doing some thinking on it, but it doesn't seem clear to me how we would do some price discovery on what the optimal price for a bond is. Yeah. So, and if there is a way to make exits, for example, I put a bigger bond and I request my exit to be faster, for example, some kind of a reverse analogy, between the exit duration and the bond that I put in, of course, with a minimum, with a cap, because I shouldn't be able to make my exit 1 second long. But for example,
so you're having an exit block size effectively.
Yes, exactly. So I'm thinking that, for example, I can put a bigger bond, 10 times the size of the bond, and you can have some sort of diminishing returns. So I put 1 ether, it reduces by 10%. I don't know. I put 2 ether, it reduces by 9%, and so on and so on.
Or you can have a more extreme version of, we say, we only allow 100 exits per block or something like that.
How would that help, though? What does that
create a fee market?
Yeah, exactly. Exactly. Whoever pays more, whoever pays a bigger bond. Exactly. But is it bad?
Okay, so one thing about this is that the actual you're giving a price for how much those locked funds are worth, and that's kind of set in the protocol. But if we have secondary markets for buying exits, then that like price of like what is the cost of the locked ETH for a week is kind of more flexible. I would say. So like, in other words, someone else can externalize that.
So you say, okay, you say that the fast exit construction with secondary markets is probably better than putting it in the protocol.
Exactly, because then we don't have to say this is the price of 1 week versus 2 weeks of locked ETH.
Yeah, okay. Okay, sure.
And economics is so hard. Like literally exactly what you're saying. Holy crap. Like I don't know. I don't think anyone knows. No one knows.
So it's better to leave it to market discount, to like put it on a secondary market and leave it for anybody, free market, whoever wants to buy it at whatever price.
That's my intuition.
Okay.
I feel like it's pretty reasonable for V1 as well, honestly. And if you want to be a little tricky later on, you can do that.
Okay, another thing then. We were talking about the optimistic exits. Wait, let me send it in the chat. Optimistic chip multi-exit for plasma cash or MVP, I cannot read. Okay, so the thing is that we're talking about this with Dan, that currently, for example, I'm always talking with respect to the thing that I have implemented so far, that the exit process, it requires a medical proof of inclusion for the transaction that you're exiting and for the parent. And I need to also prove that the coin and the previous one were included. So the chip, the optimistic thing, it says that you do not need to provide any proofs, or you just provide the transaction, and anybody can then challenge with 1 or 2 types of challenges, whatever we make it be, that either the parent was not actually included, so you're invalid, or that your transaction is regarding another coin, or that there is another transaction at that block that you're exiting from. That is the case, and this could potentially reduce the exit cost to like, I don't know, like 40,000-50,000 gas, like 2-3 S-stores. I think 2 S-stores are needed to make an exit, maybe.
Oh, nice.
Yeah, it will be a very small, like, because currently it's like 100 something, 110, 120. It could reduce it like by 60%. But it's optimistic, because we assume that we will have like the happy case with people not attempting to like do invalid exits. So how do you think about that?
Yes, the idea here is that you have to add a challenge where someone can provide the Merkle proof, saying, no, wait, that transaction you said is there isn't there.
Instead of providing the Merkle proof when you exit, you say, I do not provide it, but you're welcome to prove me wrong.
I think that's fine as long as the bonds are sufficiently high, right?
Exactly. We get back to the original.
The bonds we know are already high enough that they can pay for a Merkle proof, because you might need a Merkle proof for one of the other challenges.
No, I'm saying like, if you say you need to calculate in the probability that someone does invalid exit, right? The bond percentage of, let's say someone doesn't watch the transaction, has to take into account the percentage of people that don't watch.
How optimistic we are, basically.
Let's say 5% don't watch, right? If your profit margin, you're basically, like your ex ante return, across the board, if you griefed everyone, it needs to be effectively your bond needs to be higher than whatever your profit margin potentially is.
Do we have any student who wants to take that? Like, this is a good
like, just pick a really high number and then continually reduce it. I don't know, or pick a really low number, I guess. What is the more cynical perspective? No, I don't want to get into it.
But again, I believe that the thing is
perspective is that if you start high and then start reducing it, the second order systemic effect is that people get more and more comfortable until it like blows up. If people start choosing really small numbers, or if you start with small numbers, this is very cynical. If you start with very small numbers and it's kind of like it's very messy and breaks, and then you start upping it, you sort of know where the bounds are better.
By the way, this is the price discovery stuff that we
yeah, exactly.
Casper, like it would be hilarious to, just slowly reduce the rewards until everything fails completely.
Right,
Like,
right.
oh,
That's
now
the
I know.
problem.
Now I
That's
know.
the problem with being overly conservative, ironically, long term.
Yeah,
Alex is saying in the chat with the optimistic stuff. So we actually tried implementing it a while back, and the gas savings were not that high because the Merkle proof is relatively cheap. He's right about that. I mean, it's like a few thousand gas that you end up saving.
But can't you also skip the signature checking? The signature checking
In
is
MVP,
It's very cheap.
check the signature actually. So in MVP, when you start an exit, you just prove that it's included in the chain. The original spec has you checking a signature, but it's actually wrong. As soon as it's included in the chain, you can start an exit from it, as long as you can prove that it's actually included.
I guess
Well,
we
the
could,
signature
like,
check
run
is still heavily like it's still ridiculously cheap. The most important part is you need to store the inputs information for later challenges or output information for exit itself and first the challenges, and it's where it gets the most storage. So that's the problem.
Oh.
Yeah, just in case, I'm sorry for the internet connection. I'm in Shanghai in the airport,
Oh, cool.
so it can be a great chain of firewall.
Okay, cool. I think we hear you fine. Yeah, I guess we could run the numbers. We could even run the numbers on like what it looks like if you just don't even store the transactions and you commit to a hash of it and publish it every time or something. Explore that. I don't know. Gas is always very unclear.
You can get down to this is the thing that lets, like, you can get to 1 bit if a large number of people, 1 bit per exit if there's a relatively large number of exits.
So
but
this
then you get
eventually we're trying to reduce this to an exit with minimal information in order to make it possible to have some, like to make mass exit basically the default thing.
So one thing I thought about with this is the notion of, you know, like we were talking before about like splits and merges, and you're going to have to do that for Plasma Debit as well, essentially, in order to basically at the minimum a split. It could end up being small. I don't know if someone else has discussed this prior, so clear up with me because I could just be remembering something that someone else said. Have we considered the possibility of using like offsets instead of Merkle trees for basically, you know, instead of when you do a split, you basically say you have position 0 and you're giving someone else position, let's say 0.5 or something like that. I mean, obviously these would all be integers, but effectively every time you do a split, you effectively, it must be within that those bounds. And anytime anyone does a withdrawal, you adjust the offset.
yeah, that was
I don't know if this is actually space savings, but it's possibly something.
I think it saves a lot of space. Like basically the idea is like with a range-based thing, which is kind of what you're describing. Like people will hopefully try to get all their things in the same range.
Yeah, and the data structures on could be on the block on the block proposer side. It could still be, you know, Merkleized into a committed Merkle proof, but then, you know, when you actually adjust the data and make, you know, when you make attestations on it, you're making attestations on the range itself.
Yeah, one thing I'm worried about for those is that like there's like a lower bound you can't get past, which is that like if someone is trying to grieve the chain as a whole and they just take like tiny slices out of each range.
Yeah. Which is a problem with splitting in a tree as well. I think one thing is that it makes splitting easier. So you may have to have like, you know, depth bounds still and depth counting perhaps. So that's something you may still have to do. Or maybe if it splits in, because you don't want a dynamic where, you know, it splits into 1,000 pieces and then merge back to 1,000 pieces. And you don't want to be able to keep track of all of that, essentially. But yeah, that's something which might be possible. Intuitively, it feels like it would probably reduce the data complexity considerably, but it's sort of, you still need to be able to prove that something was modified. So at that point, you still need some kind of Merkle proof of block inclusion. So I don't know how much data you're saving. I think it's mainly on the splits and merge transactions themselves, probably. But this is just an optimization.
Dan, you had a interesting like analogy between the kind of splitting and multi-operator plasma that you were talking about. That maybe
Talking me?
Yeah.
Oh yeah, about right. So yes, that you can do plasma debit like natively. You don't need to have anything special to support it if you have the ability to do sibling merges and splits. So you can think right. So you can think of plasma debit as just being each coin is co-owned by so like you split, instead of having a single coin there, you now split it into two coins, one of which is owned by the operator, one of which is owned by the user, and debit transaction where you're like changing the balance between them is just remerged into one coin and then splitting them in a different way. And so this is a lot more flexible, one, because it allows the operator to transfer their part, or for anyone else to sort of own that piece of it. And then if you can do this with any owner, then someone else can be the liquidity provider there, and can sort of like route these payments. And so you don't have this requirement that Plasma Debit has, where the operator provides like sort of an ungodly amount of liquidity to the whole to the particular chain. And it generalizes pretty nicely. My worry generally about multi-liquidity provider Plasma Debit is that you've already got the operator having this veto power on transactions being included on the network. So adding an additional liquidity provider is sort of like having like a three-party payment channel, which like three's a crowd, right? Like two is already a really inconvenient number to work with. Like it sucks that your counterparty can just sort of like disappear or not do things, and sort of be, all this stuff is built around trying to avoid that. When you have three parties, suddenly you need unanimity among these. So like if any three of these parties disappear, you suddenly can't do these kind of transfers. It's a little different here because the operator and one of the users together can transfer their coin to someone else. But yeah, so it ends up being like, like there are all these papers with more than two-party payment channels, and they're all kind of messy and difficult, and sort of difficult ergonomics. So yeah, so I mean, it may well be worth it. I'd be curious to hear Zwanji's thoughts also on it, but it may well be worth it. But I think it's a lot harder certainly when you suddenly have like you have to deal with sort of multiple counterparties on this.
Yeah, you're right that other people agree with you, and I think that's the main trade-off.
But I would definitely love. I mean, I think we've been talking about sibling merges and splitting in Plasma Cash since like the very beginning, and I mean, I think Carl's probably done the most specific spec of it, but to actually have a full spec or an implementation of that would be awesome. So yeah, because I think it's something that we all sort of like, oh yeah, that'll work, but to really see it, yeah,
not fun.
Cool.
Wait, we have a spec for sibling splits and merges?
Yeah, well, we got Carl's the Plasma Cash simple spec, I think.
Yeah. But there's nothing about the splits and merges, I think, there.
Maybe?
No, there's no real splits and merges. It is more a nebulous cloud of ideas that we've realized are far too complex once.
I think it said it would be nice if, and then
yeah, someone figured that out,
Okay, do we have something specific? Because I see a question on ETH research, which might be interesting.
Oh yeah, definitely.
So similarly to how like private key management is an issue for like daily users, let's say that if they lose their keys and whatever, they lose access to their coins. In Plasma, the analogous to that one is losing your Merkle proofs that allow you to exit the coin. And so there's a question that says, let's say I'm a user of a Plasma chain and my hard disk drive dies. Have I permanently lost my UTXO, coins, history, branches, and all that? How can I exit my funds? I think the answer is you can't.
Is what?
It depends heavily, right? So if it's If it's MVP, it's generally not as bad because you can just query a bunch of peers and then ask for the branches back. Plasma cache is probably harder because if you're not duplicating, it's like the same problem as Lightning, where if you're the only person who has the latest state, then the other person could just steal funds. Or if you're the only person who has the revocations.
Wait, I think there's an ambiguity here. I interpret the question to mean I've lost my witness data and I've lost my private key, but because
sorry, my bad. Just my witness data. I still have my key. You still have access to the chain.
Wouldn't that force you to try and exit an earlier point in time, and then you'd just be challenged by other people?
I mean,
he means he lost everything. You don't have any data.
If you don't know your latest state, then yes, you're screwed. But if you don't know,
if operator is available, you can get it back, but the operator can withhold.
But anyway, it's true. You could ask the operator for it, and the operator could give it to you. But if the operator withholds it, I think you're still fine because as long as you know the latest state, you don't actually need all of these proofs in history. You only need that to show somebody if you're gonna transfer to them.
I presume the question is the worst case of you have your your seed wallet, but that's about it because your hard drive died.
I mean, if that's it and you don't know where your coin is, I mean, right? Then yeah, I mean, it's like any sort of like privacy coin, I guess. It's more like that, right? But if the amount of information you actually need to keep is constant. It's not constant in the number of coins you have.
So it feels like a lot of that can be resolved just by, let's say, allowing your transactions to be propagated out or something like that.
Yeah.
So propagate it out, which means
it's sort of like if you just mark your transactions as like not private or something like that, and anyone can request them.
Yeah. And then if you have a large enough bond for like invalid exits, then there's this kind of, maybe a little shoddy, but some built-in incentive for people to store your information to make sure that they can steal.
I just think like a lot of those, blockchain explorers are going to want to like keep that data anyway.
That's another one.
I feel like the best long-term solution is you're going to keep your witness data in your hardware wallet next to your private keys.
Yeah.
Is that feasible for the amount of witness data you would need with Plasma Cache?
Yeah, it depends on like how much witness data.
So maybe not just for Plasma Cache not to transfer your coin, but to exit your coin, it's okay. So to transfer your coin, you need the whole history. But in order to initiate an exit, you just need the thing and the parent. And if we do the optimistic thing, you don't need anything. Or you need like very little amount of data.
Actually, I think you need the whole history to respond to challenges.
Yes, correct.
Yes, okay, correct.
But I don't know, like I've been thinking
you don't need the whole history to respond to challenges. Oh,
you need if you get a challenge with invalid history, you need to be able to respond to it with a direct spend.
No, if you've got a coin from the future with invalid history, you just need to show your coin. You don't need to show any other coin. But
but if someone withdraws your old coin or something like that,
if someone then you need to show a spend of that. So
that's the
which is part of the history.
I see. Right. Maybe you do need to keep the whole history around just to respond to challenges.
Which is why I think the simplest solution is just to mark your data as public. If you're, if you don't really like, you're going to lose the data.
Yeah, but it's not incentive compatible. Like, why would people store your data for free? I don't know.
Filecoin.
No, people will totally do it. Purely block explorers, and like I think data availability on blockchain state is never going to be a problem, purely due to chain analysis companies. They're simply going to do it.
But I don't think we should have the assumption that Plasma Cache data is made public. I think the chain operator should not be.
To be clear, that's not good, right? Like what I'm saying, like that's not desirable. It's just a function of the system.
Oh no, but I mean, they're just not going to reveal it. Like it's private between the operator and you. Just like state channel data is not going to go in.
But we can expect that there will be an operator who has a public API, and the moment the API is public, it will get scraped and.
Yeah. But we don't want the operator to have a public API where they show the coins to everybody.
No. But I'm saying you can elect to do that if you wanted to.
Right, you could. I don't think that I don't think we want that as sort of the structure though, because
no. It shouldn't necessarily be the structure. But I'm just saying.
And that's why we have all the data availability issues.
Couldn't
Right,
you just appoint like a monitoring service or a watchtower or something like that? Like somebody that say that I trust Georgios, I'm like, hey, I'm going to go offline or my trade might get fried, and I'll be able to pay you like a small amount if you are able to like provide that to me if I lose all that information.
I mean, it's even simpler than a watchtower. It's literally just backing up your data. But yeah.
Yeah, you could use like Dropbox or something.
Right. But yes, but wait, you hopefully you also have a watchtower for when you're offline. So yeah.
Exactly.
I think Eric's point, which I'm paraphrasing, is that like you can make watchtowers to store your data trustlessly, which I think is a fair point.
Yeah.
And also challenge, respond to challenge.
Oh yeah, you might as well do that. Yeah. But
Yeah, it's just easy, and then it gives them a little bit of a reason to store. Maybe it costs a tiny bit less. I don't know.
Assuming you pay them. Yeah.
You do definitely do.
But we thought of an attack scenario in this one, which is like pretty obvious, that you have the watchtower. The watchtower puts up some huge bond, collateral, whatever, so that if they lose the coin, you can get compensated. And what you do is that you have another user try to exit the coin, like you collude with another attacker. You DDoS the watcher, and so you have your co-conspirator, like they exit because nobody challenged, and like pay the bounty to whoever.
Mm-hmm.
So doing like trustless watchtowers maybe doesn't really work.
Put it on a big
I feel like
AWS box.
Wait, there's another.
Yeah, I mean, you should have this on like 10 different servers, and it shouldn't just be from your watcher. It should just be a condition. If it gets challenged, then whatever. Because you don't care who challenges it, right? You just care that it gets challenged. And so,
we do this just with the redundancy that you pick.
There might be a way to address part of this on the protocol layer, which that it actually does seem kind of disturbing to me that if you don't have the history, someone could withdraw an old coin and you wouldn't be able to do anything about it. But I think it actually might be safe if we say when there's multiple withdrawals, the latest one takes precedence. So what happens if someone?
No, you can't do that.
What's that?
You can't do that because they can be spending an invalid.
Yeah. Well, right. So this is one thing we were wondering about. Is like what happens? So what is the protocol when you have multiple withdrawal attempts and multiple challenges? Like what exactly? How do you sort of address that? And I think it's
first in, first out.
Is it first in, first out?
By withdrawal, yeah. I mean, like that's the simplest thing because you just let that one get disputed.
I think with challenges, first of all, you might want it to be the latest challenge.
I was talking about the withdrawal transaction in particular.
Right. Yeah, so maybe
if I can't timestamp, it'll be first in, first out, and at that point, you don't need that much code.
Right.
But for the challenges, the ordering of the challenges at that point, there's a lot of.
Right.
I mean, you could do it other ways, but it just feels like it's like less code.
Has anybody talked about the case where, say, I'm like Alice is super rich, Bob is super poor, and Alice just keeps on hitting Bob with all these challenges continuously?
They're going to get penalized.
That to be able to prevent her from effectively griefing him with a bunch of challenges.
Well, Alice is gonna, like whoever's getting challenged, like they're going to get money.
well, that's actually interesting with the future challenge, because it requires that it's a challenge response. And so let's say
bonding all of it, so it'll be fine. With the challenge,
you're bonding all of it, but let's say I make 1 million challenges, right? And then in order to respond, I have to respond with a bond myself. So I have to respond bonded on all of those as well. I'll be right, but I'm the only one who has the information to do the challenge. And it's going to cost me a lot of money to respond. I could reveal it publicly and have other people do it. But
the challenges are basically like when you refute a challenge, then it's immediately resolved. So
not with the one challenge where there's an invalid future spend.
Yeah.
That's the one case where you can't do this because it's a challenge response. Where you create an invalid transaction in the history and then I respond with a previous transaction and request that you
Right,
give
that's the
me-
challenge. Yeah, so you do, let's say you do 1 million of those, right? And then let's say the dishonest party does 1 million of those. The
Mhm.
honest party, the reputation of that is a spentness proof, right? That spentness proof gets resolved immediately. So effectively what happens in a block, let's say you do only 1 per block, right? You can do that, like you do 1, and then after that you get their collateral, and you could probably end up doing like multiple after a while. And at that point it gets resolved pretty quickly.
Well, what I'm saying is that there's
Immediately
one type of
resolved.
challenge. There's in Plasma Cash, there's one type of challenge where so you try to withdraw,
Mhm.
I reveal a transaction, and I request that you provide me with a response to my challenge. And so it's not immediate. It doesn't resolve instantly. It resolves after a period of time.
Are you talking about the challenge or the withdrawal?
The challenge.
The challenge itself is a responsive. It has a response. So you, like in the 7 days that you have, for example, to finalize your exit, the challenger has like 3 days to make a challenge, and the responder has another 3 days to respond.
Yeah, but I'm saying that if you, the principal way to grief this is to put in a transaction which has already been spent, right? Or are you talking
Well,
about
what I'm
griefing
saying is that
with a
there's,
transaction which doesn't exist?
yeah, I'm saying that you make, well, no, you make a transaction, or the operator makes a transaction.
Yeah.
That's completely invalid, and they put it in the Plasma chain.
Mm-hmm.
Let's say this is Plasma Cash.
Mhm.
And so you withdraw,
Mhm.
and the
Right.
way that
So the attack vector is many invalid withdrawals, not many invalid challenges.
yes, many invalid withdrawals,
Got it.
and
Got it. Got it. Got it.
then I have to respond to
May-
each one of them with a challenge that takes a few days to complete.
Yeah. So you may need to constrain the number of
Challenges.
withdrawals.
The number of, can you say that again?
Withdrawals per output.
Okay.
Concurrent withdrawals.
per output.
Per coin.
You might be able to say
Is the
one
same. Yeah.
withdrawal
Yeah.
can happen per output at a time. Like you cannot have concurrent withdrawals.
That is my. So I saw that while we were talking about Plasma Debit, it was written somewhere that a coin can have multiple withdrawals, which I did not get. While in Plasma Cash, with from my
Okay, I mean, you could just do just one, and then maybe the one with the highest bond or something. So you can order it by bonds or something.
But the thing is that if there are 2, for example, exits, it is the same as having one exit. It instantly gets challenged, and the valid one comes through. So why allow multiple exits?
It's that one case where you have the invalid transaction that gets put in the chain, and you have to reveal a previous transaction, and then with the exit.
In this case, you mean that I cannot exit, and I'm forced to wait until that.
Yeah, exactly.
Yeah. You don't want delay griefing, which is why you have to basically prioritize by bond size or something like that.
Right, but okay, my exit gets delayed, so essentially I cannot exit because I have to wait for the challenge game to play out.
Mm-hmm.
But I get the bond. Not good enough, yeah.
Well, you get the bond, but then there's also, I mean, imagine if I have 1,000 of these and you have to put up even a 1 USD bond for each challenge, then you have to front 1,000 USD, right?
Yeah, okay. Fair.
So yeah, I guess if you order it by bond size, that's one way to do it. But I don't know.
I mean, you could also just do you could just have an invalid coin in a bunch of different histories and try to withdraw all of those different coins. And then as long as the same person is watching or
not in cash. Are we talking about?
Yeah, we're talking about Plasma Cash.
Yeah, no, in cash. I'm just saying like, I'm saying like an entity who is a watcher of multiple coins, there still can be like some issues. Anyway, but yeah.
Yeah. So watchers stop working. Watchers probably would not want to put a bond if the chain, if there's block withholding though, because you can't prove spentness. So effectively, you have to presume that the bond is being put up by the user in the worst case.
There we go.
Cool. All right. It's
Interesting.
been about an hour. That was a really fun conversation. We talked about a lot of different things, and that was really engaging. Yeah. So see you again in 2 weeks, perhaps.
Sounds good.
Bye.
See ya.
Bye, guys.
Bye-bye.